This video is about electric charge and force. You know, objects are made up of an enormous amount of atoms. We have so many atoms just in our fingernails, and many, many more just in our bodies. So with so many atoms, there's sometimes an imbalance of stuff inside the atoms. Whenever there is an imbalance of the number of positive protons and the number of negative electrons, then the molecule has what's called a net charge. If you have more positive, the net charge, of course, will be positive. If you have more negative, the net charge will, of course, be negative. You know, there's an example with rugs and doorknobs. You have probably been shocked from touching a doorknob after walking across a rug on a dry day. Your body picked up an electrical charge through your shoes. If two objects have picked up the same charge, they will repel each other. You see, the same charges repel each other. If they picked up a different charge, you guessed it, they will attract each other. And of course, these charges are called positive and negative. Objects are sometimes charged by friction, like rubbing feet on carpet. Other times, a neutral object may take a charge just by contact. Something negative even touching a doorknob may transfer the charge to the doorknob. This creates what's called an induced charge. When something charged charges something that's not charged. You know, even if you bring the negatively charged object close to the doorknob, the negative atoms will repel and the positive atoms will attract. And a good example is this balloon here. You have whatever this object is here has all the positives which are touching the balloon. All the negatives are being repelled by these negatives over here. The positives are attracted to the negatives. The negatives are repelled by the negatives. You know, you can pick up objects like this, like in a magnet, where the positive end is attracted to the negative end. This process is called polarization. And that is the basic idea behind magnets. It's also why clothes from the dryer sometimes stick to each other. The standard unit of electric charge is called the Coulomb, and it was named after a person named Coulomb. You know, you have to have many electrons to transfer to make a charge of just 1 Coulomb. Now we mentioned there are a lot of atoms, which means a lot of electrons in us. Negative 1C, which means a negative charge registering 1 Coulomb, is 6.25 times 10 to the 18th power. See, that'd be what? This number plus 16 zeros? That many excess electrons make something register negative 1 Coulomb. So these electrons, it's not just 1 or 2 atoms which send electrons places. It's a lot of atoms that can, and when you do, you have some kind of net charge. Conductors. Conductors allow electric charges more freely. The wires inside an electric cord are conductors. You see these electric cords. It's not hollow. It has wires in it. The wires are the conductors, but the insulators do not transfer charges easily. The plastic around the wires of an electric cord is an insulator. You can see it here. The cord's here, the plastic around it, and even more plastic around it. They're insulators. Cardboard and glass are also insulators. So how do charges interact over distances? A charged particle produces an electric field around it. You can represent a positive charge, like right here, by drawing lines away from the particle. This is kind of how the standard electric field for a positive charge is represented. A negative charge is represented by lines drawn to the particle. You can see some examples down here. You have two positives that the electric field is repelling each other, and you have a positive and a negative that are attracted to each other, and the electric field will connect. If you have twice as many lines, like in this one, it represents twice the charge. In this one, you probably have 3 times as many lines. So it would have 3 times the charge. And notice that some of these connect when you have the positive attracted to the negative. Well, hope you learned a little bit about electric charge and force.